Base is exploding as Ethereum's hottest layer 2 chains, powering millions of trades daily. Imagine having your own lightning fast Telegram bot that executes secure and high performance trades right at your fingertips. In this video, we will build exactly that. A Telegram bot on Base that helps you trade smarter, faster, and safer. So without any ado, let's jump into it. Before getting into the code, let's understand few key components of our bot. Our bot will be using a SQLite database to store Telegram users metadata like name, ID, username, timestamps. It will also be used to store wallet addresses and private keys of the user in an encrypted format, along with the settings for their trade, which includes slippage and gas settings. Then it will also be used, the database will also be used to store records of swap transactions, where it will store to and from token addresses, gas used, statuses, etc. For specific functions, we will be using specific APIs. For example, to fetch balance, we will be using base blockbook JSON RPC API. To get codes of swaps and to form swap transaction, we will be using OpenOcean Swap API. To get gas estimations, we will be using gas estimation API, and to send secure MEV protected transactions, we will be using MEV protected endpoint. All of these APIs are available under QuickNode Marketplace under Base DeFi Power bundle. So once you are logged into your QuickNode dashboard, just click on the link below in the description and then click on Get Bundle. Once you click on that, you will be prompted with this installation page and you'll need to install the bundle. And once you install it, you will be able to use all of these APIs on your QuickNode endpoint itself. You don't need to sign up for each and every one separately. So once the bundle is installed, you'll find the add-ons installed under the installed add-ons section of your endpoint. To get there, you just have to go to your endpoint, then go to add-ons section, and under the install third-party add-ons section, you will find your add-ons installed once you install the bundle. So as you can see, we have all the 4 add-ons which we will be using in our bot installed over here. Just one disclaimer before we get started with our code, that this code is just for educational purposes and has not been audited professionally or thoroughly. So please refrain from using this in production environments and use it at your own discretion. So to get started with the code, you will first have to clone this repository. So let's clone it. This repository has collection of sample apps across various chains. So you can use these sample apps to build your own apps on top of these. Once cloned, go to the repository, which is QN guide examples, then go to the base directory and then go to the Telegram trading bot directory and do npm install. So this will basically install all the libraries which we have used in the bot. Alright, so since that's done, let's open this up in a code editor. So this is how our code base looks like for the bot. So this has an environment variable, we have certain command files, certain library files, types and util files. We will go over each one of them, but first let's understand what all we will need in the environment variable file. So the first thing will be the Telegram bot token, then your QuickNode base RPC URL on which you have the bundle installed. Then we will have an encryption key which will encrypt our wallet using AES 256 CBC encryption algorithm, so that our private keys and wallet addresses are stored in encrypted format in the database file. Then the database will be available via this path, database.sqlite. The chain ID for base mainnet is 8453. Default slippage for now is 1%. Default gas priority is medium. So using the Sentio's gas estimation API, you get a JSON response of various priority fee confidence levels, which are low, medium, and high. And these are determined by simulating transactions in the mempool. So depending on your use case, you can set this medium, low, high. Low is 90%. Medium is 95% and high is 99% confidence. So let's just copy this file and create our environment variable file. So let's start to fill this. So the first thing will be Telegram bot token. So for that, you will have to go to your Telegram app, then go to bot father, using which you can create your own Telegram bot. So you will need to do new bot command, and it will ask you for your bot's name. So let's say our bot's name is base trading bot. Now we will need to choose a username for our bot. So base, let's say our username is base underscore trading on chain bot. Now the thing with the usernames is you cannot take a username which has already been registered by someone. So that is why I am trying to make it as unique as possible. So let's see if this is available. All right, so that is indeed available, and you will need to save this token. Now this token needs to be saved very securely, because if anyone gets access to this token, they can access your bot and basically perform any kinds of operations with your bot. So I am just adding this for the demo purposes, but I will be killing this pretty soon. Then you need to add your QuickNode RPC URL for base over here, which you can get from your QuickNode dashboard after you go to your base endpoint and get the HTTP provider URL from here. After that, you need a wallet encryption key, which you can generate by running this command over here, open SSL rand hex 32. So let me do that. So this is my encryption key. So all of these values which I'm getting for the demo, these are just for this demo session and won't be usable after this. And once you paste your QuickNode endpoint, all the environment variables should be satisfied. So now that we have the environment variable file set up, let's understand few of the other files, which are commands, libraries, types, utilities, the context file, and finally the index.ts file, which brings everything together. Let's first start with our library file, where in the first file, which is database.ts, this will be used to handle our database operations, create tables, etc. So we are using the library Better SQL 3 to handle our SQLite operations. First, we are creating the new database. Then we are defining the types for each database, for user, wallet, settings, transaction. Then we are initializing tables. We are initializing the user table with the types we defined earlier. We are initializing the wallet table. We are initializing the settings table, and then finally the transaction table. Now we have few functions to handle user operations. For example, if the user does not exist, it will create a new user. For example, if you are just starting the bot, a new user will be created using these information: your user ID, Telegram ID, username, first name, last name, if that's applicable in Telegram, and then it will insert it into the table. Then if a user needs to be fetched, it will be done via this function. To save the wallet, we will be using this function. There's this SQL query over here, and these are the types which we defined earlier: get wallet by user ID, then get wallet by address. If you want to delete the address, this function will be used. Then for setting operations, save user setting, get user settings, and then finally for transaction operation, where we will be saving the transaction using this method. And get transaction by user ID. For example, if you want to get all the transactions for a particular user, you will be able to do that using this. And get unique tokens by user ID. Then finally close database connection function. In the encryption library, we are using CryptoJS library to encrypt sensitive data like private keys. So we have a encrypt function, we have a decrypt function, then we have a function to generate encryption key, which we just did earlier. And then we have a function to verify the encryption key if it's valid or not. Then we have the history library, which is using the Axios and Vim libraries. So this library basically has two major functions: get balance history and get token balance. So basically when get balance history is called, it will be calling bb get balance history of the blockbook add-on, which is this, to get the ETH and token balance history of a particular wallet address over a given period of time. For example, it can be day, week, month. We have defined day, week, and month over here, and we are sending the request over here. So it will get the balances in fiat USD. And then we have a function to format the balance history. After that, we have a function get token balance to get the current token balances ETH and ERC20 for a particular wallet address using bb get address. Again, a blockbook add-ons function. And then we have a swap.ts library, which is one of the most important library. So in this library, we have our swap functions. We have a function to handle the error, to check if the response has error. Then we have a function to get the code, where we will be using the OpenOcean v4 swap API to get the code. You can see that we are sending the code request along with the in token, out token, and amount to the OpenOcean API, because it's a marketplace add-on. Everything is done via the QuickNode RPC URL, which is the best part. And then after getting the code, we have a function getSwap to actually construct a signed swap transaction. So you can see that we are sending a swap request along with this information to get a signed swap transaction. And then for gas estimation, we have this function which will be using Sentio gas price custom method of the gas price estimation API by Sentio. So this method will get the gas price, and then based on whatever confidence level you have set here, it will set the gas price for that particular confidence level. Then we will get gas price for a particular priority using this function. Then we will get the gas price parameters. For example, OpenOcean requires gas price in a string format in GUI, not WAY, because we usually have gas prices in WAY. So that is what we will do over here. We will convert it into a string format in GUI, and then we will have the formatted gas price over here. And then finally we have another function, get gas priority label, which will be outputting these for our users or bots users better understanding. Then finally we have a token and wallet.ts library, which handles wallet creation, key handling, and transaction signing. So we are importing all of the necessary packages from Vim over here and over here. Then what we are doing is we are also importing all the configs, types and utils. We will go into types and utils just in a second, and then we'll go into commands. So here we have the wallet functions where we have a create client. So if we want to create a new wallet from a given private key, this function will be used. Create a public client for base network, basically create a public client using QuickNode RPC URL for the wallet. And then we have this function to generate a new wallet. And if you want to generate a new wallet for a particular use case or for that particular trading session, you will be able to use generate wallet function. So all of the functions in the libraries files we are seeing will be used in the commands files. To import a wallet from a private key, import wallet function will be used, and then it will be encrypted and saved in the database. So if a wallet for a user needs to be fetched, it will be fetched via this particular function, which will use get wallet by user ID function of the database library. This function to get the private key, then to get the ETH balance, this function will be used, and to execute a contract, execute contract method will be used. This uses Vim's write contract module. Then to execute the transaction, this function will be used. And as you are seeing, we have a send transaction function over here, and send transaction function under the hood uses ETH send raw transaction. So since our endpoint has MEV protection and gas recovery API installed, every ETH send raw transaction will already be MEV protected, which gives you protection against front running sandwich attacks And this API also has gas recovery mechanism. So if your transaction fails, it will recover your gas, or any unused gas will be recovered as well. And then we have a function to withdraw ETH to another address. Then we have estimate gas price for ETH withdrawal. Then we have a function to get token info, get token balance for the wallet, get multiple token balances for the wallet, get token address by symbol, format token amount, because the token balance which we get is in base units and we have to format that based on the decimals of that particular token. Then get the token allowances for the wallet address, and that is what the token wallet library will look like, which will handle all the wallet related operations. So after the library files, there are types file. We have three types file for commands, config, and wallet to handle types for commands, config, and wallets respectively. Then we have utility files. Utility files where in the abi.ts file we are storing the ABI for ERC20 tokens, smart contracts. We have constants where we are storing native token address of ETH on base. We are storing token addresses for a lot of tokens on base. We are storing constants like default slippage, gas priority levels, confirmation timeouts, allowance amount, etc. Then we have formatters where we have different functions to format ETH balance, to format token balance, to parse user input amount into way, a method to format token balances to display on Telegram, etc. Then we have a function, keyboard helper function, which helps us display buttons under commands from the bot. So buttons like yes, no, low, medium, high, etc. So this utility function will be used for that. Then we have a validators file, which will help us validate addresses, validate string of private key, validate the token amount, validate if the wallet address has enough balance for transaction or not, validate slippage values, gas priority values, all of that. Then comes the commands files. So we have this balance and history command file where there are two kinds of commands. One is balance, of course, and then the other is history. So the balance command will show current ETH and filter token balances, and the history command will show those token balances history. So both of these will be using the methods which we had defined earlier in the library files. So methods like get ETH balance, get token balance, get unit tokens by user ID for the balance command, and for the history command we will have get balance history. So basically all of the commands which we are using over here uses either one or combination of modules or functions which we had already defined in the library files. So similarly in the buy command file, we have the buy command, which will be using the get wallet, get ETH balance, and then constructing the transaction, sending the transaction, etc. All of that. So this basically has all the functions to handle the buy transactions, and similarly this file has for deposits, token deposits, and this to handle import and export of wallet addresses. If you want to import wallet address basically via providing your own private key, if you want to use your pre-existing wallet, you will be able to use that via calling the import command, and that will be handled by import handler. For import handler, we will have handle private key input function that will help the import handler, and similarly for import handler we will have export handler as its counterpart. If you want to display private key with confirmation prompt, or if you want to export the private key of the wallet being used in the bot, this function will be used, and for that we have handle export confirmation function. For sell, we have this file to handle all the sell commands where it will be used to sell ERC20 tokens for ETH. So you can see that we are using all the functions from get token balance to get unique tokens by user ID, basically to get the balances and tokens held by that particular wallet addresses which is being used in the bot. Then functions to handle token selections, get token info, etc. Then this file to handle settings command, basically to set slippage or gas priority. So we will have function to handle both. For example, update slippage and update gas priority. Then there is this function called start help, which once called will send out all the basic information about what the bot can do. For example, as you can see over here, this function will be called whenever you call the start command or whenever you click on the start button while chatting with the bot. So then comes the wallet file, which will be called via the wallet command, which is used to show the wallet address and the type of the wallet. Then comes the withdraw, where the contents of this file or the functions of this file will be used to withdraw ETH to another address. So we also have a context.ts file, which helps us maintain the context for a particular user for a particular session. So this file we use in all the commands so that the context for a user is maintained within that session. And all of these we use in index.ts, where we import all the things, we import all the commands, we initialize the database, we get the .env config, we verify if the encryption key is set or not, we initialize the Telegram bot, and we set up the session middleware. We register all the command handlers, and we also have callback handlers for our bot so that all the callbacks related to the commands can work properly. And then finally we start our bot. Let's run our bot. For that we'll have to do npm run start, and once we get a message saying starting base MEV protected Telegram trading bot, so let's go to Telegram. Then to talk to our bot, either we can search for this username or we can just simply click here, click on start. As you can see, we have gotten the initial commands, and to create a wallet we can do create. To import a new wallet we can just click on import, and then we will have to send the private key over here. So let's say that we do not want to import a wallet, we want to create a new wallet. So as you can see, we have successfully created a new wallet. You can also export the private key over here. It will ask you that are you sure you want to proceed. So let's click on no for now. Let me fund this wallet really quick. Now let's try to buy tokens for ETH. So let's do buy ERC tokens with the ETH. So your balance is this much. Select a token to buy or choose custom token to enter. So let's say that we want to buy DAI. Now it's asking for how much amount of ETH we want to spend. So let's say that I want to spend 0.001. Getting quotes for the trade. So this is the quote, and as you can see, our default slippage was 1%, so that's what it is. If I click on yes, it's preparing my transaction, executing my trade. Alright, so as you can see, I have successfully bought the tokens. So I had swapped 0.01 ETH for DAI. You can basically use any of these functions. You can even sell your tokens for it. So let's say that I want to sell my DAI for ETH. So it fetched the tokens which I have except ETH. So correctly I have DAI. So please enter the amount of DAI you want to sell, or I can even type max for maximum. So let's say max. So transaction details, it has got me the code, and if I click on yes, I'm approving the transaction, and that's it. The token approval was successful, and then the transaction was executed. So this is how you can create a smarter, faster and safer Telegram trading bot using a set of powerful base APIs. So hope you learned something from this video. Give it a thumbs up, subscribe to the QuickNode YouTube channel, and I'll see you in the next one. Bye bye.